Hello and welcome back. Guess what? It's more level design. This is going to be a short one on tools and methods to help with level design. So, without further ado, here's a list of what we'll be talking about. We're going to be talking. Oh, sorry, my laser pointer's still on. So, in this video, we'll talk about ways that you can design levels, tools that you can use to do that. So, annotated maps, flowcharts, level arcs, and level arcs are not covered specifically here, but think of level arcs as kind of like your narrative layout. You can use Freitag's pyramid, which is like you remember that from the hero's journey and story part of formal and dramatic elements of games. So you have like an inciting incident, some rising action to a climax, some falling action to a conclusion, and you can map out level events and parts of levels to those points and help you set up your structure. Wanted to get that out because I don't have a slide for that. It's relatively simple. Anyway, so yeah, level arcs, narrative arcs is maybe a better name for this. You can also use event diagrams or storyboards to design levels or set pieces. And then we'll take a brief look at object-oriented and dense level design. So let's get to it. First, annotated maps. This one is fairly simple. This is maybe I think what many of you are thinking about when we think about doing level design. This is simply drawing out a map of the space and placing, enemy locations, items, objectives on it. Fairly simple. This helps you do the layout for all of your level geometry and starts to give you an idea of what that space would look like to play around in. Up next, maybe you're not interested in doing a full map, but you have a series of events that you want to design a level around. And so flowcharts are extremely helpful in that kind of situation as well, especially when you have a level where the player is going to be making some decisions that might affect the flow of gameplay. So in this case, what we see here is this is a level from Halo. So it starts at the crash site. These blue bubbles are enemy encounters. So all the places where the player might be fighting against a group of enemies. White boxes are just events. So these are kind of like main points in the flow of the level. So start at crash site, find soldiers at a base. And so these are like kind of the events that string other encounters together. These orange boxes here, and again, format is up to you, but I'm explaining this in the context of Halo. These orange boxes are indicative of areas where there are locks or other requirements that need to be met. So in this case, a player would need a vehicle in order to enter a facility. So in order to get that vehicle, they have to engage with a group of enemies, get some objective, and then return. And so you can, again, if you'd like, you can follow this flowchart all the way through in the slides and look at the way that events, encounters, and bottlenecks are kind of strung together. But this gives you a general feel for how this level should play, how intense it would be in terms of story and combat, and where the places are that a player might get stuck or might get slowed down. So this is one interesting way of thinking about how to lay out the main events or the main parts of a level, either before or instead of doing some kind of annotated map. All right, up next, level arcs. And for those of you that love graphs, this is a great way of thinking about it. Basically, what we've got here is a couple axes, and the bottom axis is time. So this is like how far through the level are we from beginning of level to end of level. And in this case, this is a graph of the tension in the narrative or the tension that a player should be feeling. This graph in particular is of the tension in I believe a Mass Effect level. But you can see generally throughout this level, as the different events happen, there is an increase in tension, and we see like peaks and valleys. So peaks are like encounters or battles or chases, and after each of those kind of like main tense parts, there's like a smaller there's a valley of a period of less tension where the player is exploring something or having some amount of conversation or some discussion with their party. And so this tool is helpful to you when you're trying to think of, again, the emotions or what you want your player to feel while not overwhelming them or overstimulating them. So again, you can map out what you intend here and think about the events that fit along the kind of emotional curve that you're interested in delivering in your game. Up next, we got storyboards. This is kind of like a mix maybe between your flowcharts and your annotated maps. Storyboards you probably are familiar with through your animation class. And so they are, again, very similar, but just in the context of level design. So events at the beginning of the level, key points later on, maybe like the climax of the level and then the end of the level. And you would describe, you'd have a sketch of what that piece of the level might look like. You would have some notations of, important pieces like new abilities or enemies or, solutions to puzzles. And again, this helps you set up the framework for your level as you work towards building it out in your game engine of choice. For those of you that are technically minded and that are more comfortable on the programming side of things, you might want to take an approach, an object-oriented approach to level design. And there's still a lot of design knowledge that's required here. You still have to understand how all of the pieces of the system work together. So the objects, the mechanics, the characters. You need to know all of those pieces within the scope of a level, and then how they relate and interact with one another. But by having designing your game in a modular way such as this, and using kind of the same principles as OOP, where you think about what parts of your code or what parts of your class can be reused, what's a parent and what's a child, all of those things, this gives you a good framework to basically like reuse assets and build levels quite quickly, because you have all of the, for lack of a better term, all of the pieces, and and have properly designed and coded how they interact with each other. So like how doors are related to rooms, how many enemies spawn in each type of room, that kind of thing. A good example of maybe object-oriented level design is looking at the way that rooms string together in games like Binding of Isaac. So each of them have their own rules, they have their own bits of randomness, but they are modular enough that you can simply plug all those pieces into the game's like internal generator, and it will build out levels successfully using that kind of approach. This doesn't have to be levels that are generated randomly either. It can simply, object-oriented level design can simply be a way to reduce the time cost of like building your own assets by, again, reusing and recoloring different things. Next is dense level design. This is, in broad terms, kind of like the Metroidvania style of designing levels. This is the kinds of levels where a player might not be able to access all parts of a level on their first visit or their first kind of traversal of that space. And that's kind of where that name dense comes from, is that a level might be very dense with different opportunities and different requirements. So, future mechanics or future abilities that a player obtains later in the game or later on in a story might be useful to access hidden parts of an earlier level, leading players to see more possibility and explore more of the space. This kind of level design naturally requires the player to backtrack to different spaces, again, to try out new new abilities or try out new items or combinations in spaces where they've perhaps been signposted that, hey, there's something here that you haven't been able to access yet. Whether it's like a different kind of lock on a door, or maybe something else that's shown through the environment that they are then able to realize and say, oh, I remember this from this previous level. I should go back and try my new ability there. So you see examples of this in different places. It's not just Metroidvania games. Like, it's not just Hollow Knight and Metroid and the Castlevania or the modern, let's say, Castlevania games that do this. But you can also, like, the Devil May Cry series does it even, where throughout the story, players unlock like different weapons for their characters and different abilities, and those abilities are useful in earlier levels and in some iterations. I think DMC, like the edgy reboot, was maybe the most prominent example of this. But like, every couple levels the player gets a new weapon, and on like level 4 or 5 they get a weapon that like smashes holes in weak walls or something. But in level like 1, 2, 3, there's definitely a bunch of weak walls that lead to consumables or hidden areas that a player can then go back to and find those secret pieces. So in some cases, like, dense level design can be like the point of an entire game, or in that like DMC style example, it can simply be something that you might use to appeal to the achievement or achiever style players, where they have to like get everything and explore all the different corners of the map. And the last thing that I will talk about is kind of procedural elements in level design. I talked a little bit about random generation. Random generation is hard to do because, again, before I get into all this stuff on the slide, keep in mind that when you're building a system that generates levels randomly for you, it's not necessarily easier, because in traditional level design, you, the designer, are going through the process of saying, okay, this is how the level fits together. This is why all these pieces work together, and this string of objectives or whatever is going to create a meaningful challenge. When you try and take all those pieces and then feed them into a random level generator, for example, it's not that you're skipping that part of the design job, but that part of the design job becomes, you, the designer, are not designing exactly how all this fits, but you're teaching your system how to design, which is a little bit, it's a different way of looking at the problem. So when you're using procedural elements in level design, you do have to do some design work. Pieces of the game, rooms of the game, rules, or maybe even full scenarios are already pre-designed. They exist. You're just asking the system to put them together. The game system takes those pieces of the game, whatever it is that you're randomizing, chooses and arranges them based on some amount of randomness. And really, like, the reason why you would do random level design in some cases is, like, if your mechanics are good and your game has a really solid foundation, you basically have given yourself an endlessly replayable game. But do keep in mind that doing procedural generation in a way that is good, in a way that feels natural, and in a way that, like, doesn't sometimes arbitrarily get the player stuck somewhere, that's very hard. It's kind of like a bit of a gamble if you're earlier on in your design career, and don't have as much of a feel for how all these things should work together. So on one hand, you could have an immensely successful game that is endlessly replayable, and on the other hand, there could be like a small piece that it breaks or like soft locks your game, if you're familiar with the saying, putting the player in a position where they're unable to succeed. And of course, random generation in games is not always just placement of rooms and objects. It can be, the Binding of Isaac style, where yes, it is randomly placed rooms, randomly placed objects within them, randomly placed enemies, randomly placed items. Sure. Games like Spelunky randomize the level layout, but that's it. It's kind of like, again, items, shops, monsters. It's a 2D side-scrolling implementation of kind of the same thoughts and ideas in Binding of Isaac. Faster Than Light randomizes the map, but really just it randomizes events that the player encounters throughout the map. And then again, if you're really deep into random generation, games like Disgaea randomize almost everything, from enemy placement to puzzles that are available to number of units on the map, exits to the next level, all kinds of things. And so you can look for randomness in a lot of places, and you can design randomness into levels in a lot of different ways. You just have to make sure that it fits your game, and again, make sure that you're doing it correctly. Doing it correctly is maybe you're doing it in a way that is effective and that does not break elements of the game. So we lost it just there for just a second, but that's going to do it for this week, I think. So thanks very much. I will see you in class.